Okay, for example number 7, we want to be able to identify horizontal and slant asymptotes. So let's talk about this definition. Horizontal and asymptotes of rational functions. The horizontal asymptote of a rational function can be determined by looking at the degrees of the numerator and denominator. The degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is that y is equal to 0. If the degree of the numerator is greater than the degree of the denominator by 1, then no horizontal asymptote exists, but a slant asymptote does. If the degree of the numerator is equal to the degree of the denominator, then a horizontal asymptote at the ratio of the leading coefficients. So let's take a look at these examples. For the functions that are listed, we're going to identify the horizontal or slant asymptote. And then for these solutions, we will use f of x, which is equal to p of x over q of x, where the denominator cannot equal 0. So let's take a look at the first one for part A. We have g of x, which is equal to 6x cubed minus 10x over 2x cubed plus 5x squared. So the first thing we want to do is look at the degree of the numerator and the degree of the denominator. Well, if you notice that the degree of the numerator is 3 and the degree of the denominator is 3 as well. So we can find the horizontal asymptote by taking the ratio of the leading terms. So that falls in to this last one. So the degree of the numerator is equal to the degree of the denominator. Then we're going to take a look at the leading coefficients, which is 6 over 2, which then y is going to equal 3. Now let's take a look at the next question, which is part B. So part B is asking us, with the function h of x, which is equal to x squared minus 4x plus 1 over x plus 2. So if we take a look at the degree of the numerator, which is 2, and the degree of the denominator is 1, so we can see that the degree of the numerator is greater than the degree of the denominator. Now, if that is the case, then there's no horizontal asymptote, but there is a slant asymptote. And so what we need to do is we would have to divide and find the quotient. So we're going to take x plus 2 and divide that into x squared minus 4x plus 1. Now remember, we can use synthetic division, so x plus 2 is equal to 0, and so therefore x is equal to negative 2. And so therefore we have negative 2. Negative 2 times the value of 1 is negative 2. Negative 4 plus negative 2 is negative 6. Negative 2 times negative 6 is 12. And 1 plus 12 is 13. So therefore, this is the remainder. So the quotient is going to be x minus 6 with the remainder of 13. So the quotient is x minus 6 plus the remainder. And so the only thing that we need to be concerned with is this part here, which is the quotient. So therefore, this should be x, the quotient is x minus 6, and the remainder is 13. And so there is a slant asymptote at y equals x minus 6. Okay, the last one, we want to take a look at part C. In part C, we have the function x squared plus 4x over x cubed minus 8. So we want to take a look at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 2, and the degree of the denominator is 3. So we can see here that the degree of the numerator is less than the degree of the denominator. So there is a horizontal asymptote at y is equal to 0. And that applies to the first part of our definition, that when the numerator is less than degree of the denominator, then the horizontal asymptote is at y is equal to 0.